All right, now let's do a little dry side design 101, how to use this tool in HVAKR. So now I've got an unfinished project where I haven't started my dry side design at all. And in fact, dry side design actually starts with your profile system criteria. So here, this is where you create duct types and set the sizing parameters for those duct types. That's what you're going to use when you start to lay out your ductwork. So I've already set this up. I've got medium pressure supply, low pressure, return exhaust, and outside air. And I've got my sizing parameters here. I even have max heights set. And what this is gonna do is determine how big of a round duct can I get before I switch to rectangular and start going wide instead of high. And then I can also set liner thickness if any of these duct types have internal liner. That's gonna make sure my free area is sized properly, and then the exterior dimensions are going to be true to that actual duct construction. So once these are set, you have everything you need to start your dry side design. And in this case, I've already done loads, I've done my air balancing, I have my CFMs for all these spaces. I can adjust my view up here so I can turn on a space view. And this is gonna show me my spaces and all the CFMs for each space. I can also turn on a zones view, which will show me my zones, or I can do a systems view to see where my systems are. So you might be in one view or another based on which step you're at in your dry side design. So let's start with spaces. And first, I'm actually gonna start from a clean slate here. My workflow, I will start with my register layout. So let me just do a few zones at the bottom here to demonstrate. Over here, your equipment palette, you'll have your central equipment ready to go. This is based on your system naming. You've got terminal units. This is based on your zoning. And then you have registers. So we give you supply, return, and exhaust registers. These are global buttons. So I can adjust what that global button does. If I want this to be a 36 by 36, I could do that. So every time I click this, it's gonna be a 36 by 36. Or more likely, a 24 by 24. So this is how you can set some of your global templates. And then this would be the tag for my 24 by 24 ceiling diffuser. Over here is a 12 by 12. I might change this tag to SG-2. I'm gonna also set what my pressure loss might be for that diffuser. And it's not so much for the diffuser, it's more so for the manual volume damper. Any sort of pressure loss you want associated with the end of your duct run, you can set that there. I'll show you what kind of pressure calculations we do in a second. So first, we're just getting this thing set up. So I'm gonna do a bunch of 24 by 24s, keep it simple, and get my duct layout on here. I'm gonna make sure my annotations are on, like this, so you can actually see the CFMs as I place them. So if I were to place all these more or less dead center, you'll see it's annotating it with the CFM based on my air balancing here, 270, 180. Now I'm gonna go along the line and do a bunch of these office spaces here. Maybe this one has 2. See, that's 150. But if I place another one in here, it's gonna split that up for me and round up to an even number. So let's place these. I'll do a couple in here. And that should do it for now. So now I've got some registers placed, and I'm going to next place my terminal units. You can do this in whatever order you want. This is just how I do it. So when knowing which terminal unit to place, I turn on a zone view, and now I can see, okay, this is zone 1-8, this is 1-10, this is 1-9, and so I can go here and find 1-8, and now I can decide where this is gonna go. Maybe I'm trying to keep these all in the corridor here, so I might place that here. Once you've placed it, you can right-click and rotate this. So I'm gonna rotate it like that. And in this case, the way I've configured this system, it's air handler serving VAVs. So this is gonna be a typical VAV layout. If this were a fan coil unit, you would see a supply out and a return in, as well as an option for ventilation air, outside air ducted in to the box. But with VAVs, you'll see this. So let's get a couple more in here. AC 19, this may be here. Rotate that. AC 110. Let's go here. Another thing you can do is you can adjust where the inlets and outlets are on this guy. So for these, I'm actually gonna adjust this for a side tap off the plenum and then it'll go down to these spaces. All right, I'll just do those 3 zones. You kind of get the idea. Next, I'm going to determine where my air handler is going to be, where my system is going to sit. So in this project here, if I go up a level, I'll see I have a mechanical room here. I'm going to use some of that space as a shaft. So if I go all the way up to the roof, which I don't have a drawing for, my system unit is going to sit right here. So I can quickly check, okay, what system am I doing here? VRF1W. I didn't rename it. This is going to be an air handler, not a VRF system. But VRF1-W is my system name, and it's going to sit right here. So I'll go ahead and place that unit. Let's rotate it so it looks like this. And then with these units, you can also adjust the size. So this is kind of a default giant air handler. It's not going to be that big, so I can adjust this down in size if I want it to be to scale to the kind of equipment I'm actually selecting. So that's an option there. With this piece of equipment, you can also add some pressure loss for system effect, anything you want to account for related to this unit. So now that I've got this placed there, I'm going to draw my risers. Now, to draw a riser, you go down here to ducts and fittings, and you're going to choose the duct type you want for your riser. And instead of clicking this button, you're going to click this button right here, riser. So this is medium pressure supply riser. I'm going to place that. Now I'm going to right click on it and define which levels this riser spans. So this is going to go all the way down to level 1, and then level 4 is my roof level. Even though I don't have a drawing for it, that's what it is. So now when I go down a level, I'll see where that sits. And I can even adjust it and say, actually, it's going to be right here. And I can go down and see there's the riser coming out. It's going to go in and down the corridor. So with that set, I'm going to draw my main duct here. This is medium pressure supply, but instead of the riser button, I'm going to select this button. So now I connect to my riser, and I'm going to draw my kind of skeleton for my system here. So let's go out to here. This might span and then go up, kind of like this. But I'll just stop there because I'm just going to serve these. I could build out the rest of this. Maybe the riser splits and goes up and covers both ways, but we'll stick with this for now. So medium pressure supply main is set. Now I'm going to connect to my terminal units. So I go out like this, like that, like so, finishing out my medium pressure supply, like this. You can make some adjustments to this after the fact if you want to get really clean with it. Be meticulous, to each his own. But there we have it, my medium pressure. Before I do my low pressure, I'm going to go up to the roof and see I adjusted my riser here, so I might set this up a little bit more like that and connect to my central unit like so. So now I'm connected and looking good. There's that. All right, let's go back down and finish out the low pressure. So now I'm going to switch back to a zone view just so I can see, okay, this terminal unit is serving these registers here. That's the zone they're in. If you got it locked in, it might be easier to just turn that off, keep it nice and clean. So now I'll switch to low pressure. The reason is because I have different sizing requirements for medium pressure than I do for low pressure. So low pressure, I'm going to draw off of this. Maybe it comes out here, spans over, and then connects to my register. Let's get that nice and perpendicular. And then I may come off here and tap into that. Very cool. AC1-9, I'll fill that out as well. So let's go out here. Of course, I'm right on the wall. I'll make an adjustment after the fact, actually. So let's do that. We'll go this way with it and connect here. Now I'm going to actually tweak this to get off of that wall there. That's better. That's probably not preferred either. Framer is not going to like you for that, so maybe I'll adjust that. So you might do something like that. And then lastly, we've got this last zone, AC-10, and I'll do that for you. So coming out, a little crisscross, and here we go. Okay, so that's built out. It's connected to my medium pressure. It goes all the way up to my air handler here. And right now I can actually go ahead and hit size. So based on all these CFMs, we know how much CFM is in each duct segment. And when I hit size, it uses the sizing parameters for that duct type to determine the minimum duct size. And I can go in now and actually override this if I want to. I can click on this duct segment and see with 330 CFM, 10-inch round, this is the actual pressure drop and velocity. I can play around with it. So if I want to go with an 8-inch round, it'll show me what's happening. It becomes a ductilator at this point. I can see right away, oh, okay, that's why it's 10-inch. I'm over on the pressure drop. And so let's go back up to that, switch to default. I can also switch to rectangular and start playing around with these values too. So maybe in this particular section, I don't have 10 inches in height, so I need to switch to rectangular and do something like 8 inches. I can do that and see whether I'm still within my sizing parameters. What about 6 inches? No, I'm not. So this is a great way to go in and fine tune your ducting after you've done this sizing. So that's the sizing functionality here. One thing to note is when you start manually changing your duct sizes, the program is hands off at that point. So if you've manually overridden these duct sizes and then you go make some changes to your loads, those duct segments that have been manually changed are not going to revise. They're kind of locked in as a manual override. You'd have to revert to the default in order to see them changed automatically when you update your loads. If all these CFMs changed, they would have to be in the auto-calculated mode to update accordingly. So just be wary of that. All right, so let's talk about return. If it's ducted return, it's very similar to what I just showed you with the supply. That said, if it is more of a plenum return, there are a couple tricks that I want to point out to do that properly. So let's say you've accounted for all the return and you're going to provide transfer out of all these rooms back to the corridor, and there's going to be one main return grill for all of these zones, for the whole system even. This is how you do something like that. So let's start back up at the unit. We'll do something like this. I'm going to have my return duct. Maybe it comes out, or maybe it comes off the side even, and it's going to go, and the riser is going to be right next to the supply riser. So now I'm going to go to return riser, connect it there. Let's make sure this is going from level 1 to level 4. There we go. And you can see that spans down to level 1. So now this return might just tap out here, and I'm going to have one grill sucking all this air in. The way you do that, because these grills here, they pick up the air for the space that you place them in. Right? If I can click on this, I see the spaces are this office, the one I placed it in. You'll also notice this button, manually assign spaces. That's really important if you're going to have a register that's serving more spaces than just the one that it's in. So return, in my case here. I'm going to add my return register, make it a sidewall, and it's going to go right around here. Rotate that so it's showing the right direction. And you'll see it says 30 CFM. That's because I placed it in this little interior corridor with really no load. There's not really any airflow in there. So what I have to do to account for all the airflow I want is click on this register, and then I'm going to manually assign the spaces that it's serving. So this register is going to be serving all of these spaces that I'm designing for. And I'd go through, and if it's for the whole system, I'd click all these spaces for the whole system. And now, when I go in there, I'll see the correct amount of airflow. So now I can connect the dots here. And when I hit size, this return duct is going to be sized appropriately as well. So that's how to handle ducted supply and then return through a plenum by manually assigning spaces to a certain register. You may have the same use case when you're doing supply. If you've got one grill that's blowing across a big open space that you've divided up, you can account for it that way. Okay, last feature to show you is the calculate pressure, aka critical path feature. So this button right here will calculate the critical path for each system that you've drawn. So in this case, I've got my system supply and my system return. So over here, I've got my return. It's really just that riser. It drops down, goes to the unit. It's highlighting the critical path. Pretty easy because there's just one path there. But on my supply side, it finds the path of most resistance for me. And you may have guessed it's the farthest diffuser, but maybe that's not so obvious. Perhaps it was this one or this one. This eliminates the guesswork. And you can imagine if this is a massive, fully built out project, your critical path might be some diffuser on the second floor with some funky fittings that's going on, instead of just bottom floor farthest diffuser. So this will do that for you. And then if I break this out, expand this here, this is going to show me all the different components in that pressure loss calculation. So this is my overall, but then as I click these and look at them, it'll take me there and show me what the pressure drop is for each of these. So at the central unit, I did not set any sort of system effect. So there's 0 pressure drop there, but then there's a straight with a little bit of pressure drop. This fitting, this hard 90-degree turn, shows me that, has 0.08 of pressure drop. Let's show you some more about that. So when I click on something like a fitting, and I can click on it here, or I can click on it on the canvas, it will show me a bit of a diagram for that fitting. Path A to B, these are the CFMs, the velocity, the area in your ductwork, and then this is the loss coefficient for this fitting. The loss coefficient, you'll see it's 0.3. It's 0.3 based on my defaults. So in fittings, next to ducts, I have fittings. I can set what my default loss coefficients are going to be for some basic fittings. So 90-degree elbow, 0.3. Transition reducers, 0.15, so on and so forth. And what HVAKR does is, instead of making you choose a really specific SMACNA part number fitting, it's going to kind of give you these building blocks, and then based on what you draw, it may be a combination of these, and your loss coefficient is going to be a combination of what's going on with that fitting. So here's an elbow, but let's go to one that's a little bit more complicated. So I'm looking at this one. 12-inch duct. I've got a Y diverging going to an 8-inch duct. I've got a 10-inch duct over here, a few different paths. I've got path B to A. So from B to A, it's saying I'm doing a Y diverging plus a reducer. The loss coefficient for that path is going to be 0.359. So this is what we've done to simplify things. If you're going through your critical path and want to get a really fine-tuned external static pressure calculation, you could just go through that critical path, look at these fittings, look at these numbers, and make any adjustments to these as you need to fine-tune it. So this is a generic fitting, but if you've got a specific SMACNA part in mind, you can go find that true loss coefficient. Maybe it's 0.37, and you can adjust it here. With each of these, I could also just hard input what my pressure loss is for this path. So path B to A, I might say, hey, forget the loss coefficient calculation. It's going to be 0.1 inches of pressure loss, and that overrides whatever calculations are done here. You've hard input it. Then I've got path B to C over here. It's a reducer there with a Y main. And so this is going to show you the loss coefficient for that as well. And then lastly, if you are doing this pressure loss calculation, whenever you find a component like this terminal unit, this is where you can go in and input a pressure drop for this component. So it starts off with 0, but you may want to input 0.1, 0.2 pressure loss for the coil, any filters you might have, any dampers right here. So you can account for extra pressure loss here. You can account for extra pressure loss at the central unit, like I mentioned previously. And then at each register, you can account for extra pressure loss there as well. So all those things go into using this dry side design tool to determine critical path and size your fan. What is the external static pressure? So I believe that covers it. That's a great primer on the HVAKR dry side design feature. Thanks.